Okay, let's pick up where we left off on part one of this video. You'll recall that we created a garage floor and we had to think about a couple of things when we were creating it. Number one, where were we going to go to create it to where we can see the boundary walls that are going to define its boundary? And then also, how are we going to make sure that it is aligned properly with the top of the foundation wall as it should be? So remember that we created a couple of section views, and again, this is something that we do quite often just in the process of creating things, of modeling. We also might create 3D views or other types of views just for modeling with the intention that we're going to delete those things when we're all done. So here I'm going to go ahead and turn on thin lines. You can see that that garage wall, or floor rather, comes in and ties in with the foundation wall right here, just as it should. Now you might remember that some discussion about garage floors sloping, and we didn't actually model this floor to be sloping. Oftentimes we don't necessarily model things exactly how they're going to be built just because it adds complexity and time to the modeling process that isn't really necessary. So we can certainly handle the slope on that garage floor in another way, namely we can put a note on here that talks about the direction and how to slope that floor. The floor doesn't actually slope, and we're going to talk about how to make it slope if we want to a little bit later in this discussion. But for now, that garage floor should and does align with the top of the foundation wall. So let's take a look at the first floor, which is what we're going to tackle next. And we really, before we start drawing floors in, we need to make sure that we have an understanding of what that floor is doing relative to the rest of the house. So when we create a main floor in this area right here, we're creating it at the floor one level, but we're not going to run it all the way into the garage for obvious reasons. Those are separate construction zones, you could say. And there's actually going to be a step down between this part of the house and the garage part of the house, because here we have a spanning floor going through the system that is sitting on this foundation wall. So the thickness of whatever floor system we're putting in is going to cause it to step up from the garage floor. This is the reason we oftentimes see steps from the garage into the house. So I'm going to move this section over just a little bit so we can kind of see what's going on there in 3D. And you can see that here's the top of the foundation wall. Here's that wall that defines the boundary between the house and the garage. We're going to go ahead and change this to fine. So you might be wondering, well, what's this business right here? What's going on right here? This is actually one of the basement walls. This is the wall that is a 2x4 furred wall with one layer of gypsum board on the outside that goes right up against basically our foundation wall. That's going to be where we would add the insulation. So let's just kind of jump to the basement real quick, make sure everybody understands what that is. And you can see that this wall right here is what we were looking at. So usually when we're doing a basement plan, especially in a region where there's a pretty cold winter or pretty hot summer, that's going to require a certain R value on that exterior. Even though it's below ground, we're going to fur that thing out. We're going to run our utilities through there and our insulation. Okay, so that's what we were looking at with that section view. And that wall kind of comes up to some sort of unknown location right here. There's no elevation markers indicating, but we know that that's actually where that floor is going to go. We can tell that because of where this door is at. We placed that door on the level 1, so the bottom of it is aligned with that level. So all we're looking at here are these furred walls right here and right here, and then beyond is the exterior wall. So that entire floor system is going to sit on this foundation wall, and it's going to run all the way up to this level, this point right here basically. Now, where we placed level 1 when we first created this project was determined, and we're going to have another separate conversation about this in the future, but if you're wondering, well, how do we know how high to place that level above the foundation? The answer is we have to engineer the floor first. And part of engineering the floor is figuring out how big the joists or trusses are going to be, and then accommodating that by raising the top of that floor up to accommodate the floor, the subfloor, the floor structure, and then anything else that has to happen underneath that, like the mud sill. If we shift to an exterior elevation view of this house, we can come over here and take a look at the different elevation markers. You can see that the top of the foundation is set at 97 feet 11 3/4, and then the first floor is at 100 feet 0 inches. So that gives you an indication of that space that's been left, that's been set aside to accommodate the thickness of the floor plus the mud sill. It's essentially 2 feet, right? And so these are some fairly large trusses that we're going to be putting in there. Okay, enough talk. Let's go ahead and make a floor. So we're going to go to the floor tool on the architecture tab. We're going to click on that. It's going to give us the default, which is the architectural floor. And a couple of settings that we want to make sure that we're paying attention to. Number one, we don't want an offset because we have walls that we're going to trace. We do want to extend into the wall, to the core. I'll explain why in just a minute. And then we need to select the correct floor type. So I've already created a floor type for this purpose, and it is the truss with 3/4 inch subfloor. Before we place it, let's take a look at it. So select it, click Edit Type, and then click Edit Structure. We go in here and you can see that this one is indeed a pretty thick floor. We have a 1 foot 10 deep truss indicated in here, and I don't have a material assigned to that, which is fine for now. And then on top of that we have the sheathing, the plywood sheathing, which is another 3/4 of an inch. So you can see that this is 22 3/4 of an inch thick, which lines up pretty good with the gap that we left for our mud sill and our floor system that we were just talking about. So we'll go ahead and cancel out of that. Don't want to change it. And now we have to define the boundary. Okay, so this does require just a little bit of thought. Remember that the boundary is typically going to follow where we place the reference planes, and those are typically going to be aligned with the outside face of the stud wall and the concrete, right, the foundation wall. So as long as we follow that reference plane, we should be in good shape all the way around the perimeter of just this left part of the house, not the garage. So I like to use, whenever I can, the Pick Walls tool. Unfortunately, sometimes it doesn't go to the correct portion of the wall, but if you watch carefully, make sure you have thin lines enabled. You can get your cursor pretty close to that, and then when you click, you'll see where the magenta line shows up, and it did happen to hit the target this time. Now that you've hit that first target, it's fairly straightforward to just go around and pick the remaining walls, and it will usually stay right on the alignment of that exterior layer that is your boundary. Now when you get to a situation like this where you have two separate walls, we typically only want to click one. You only want as many magenta lines as you need to define the boundary, and this one can be extended up, and I'll show you an easy way to do that. We're just going to click Trim Extend to Corner, and we're going to pick this line and this line to extend that single line all the way up. I could have picked this wall and had two segments in this edge right here, in this boundary edge, but that's usually not best practice. So avoid that when you can. When we're done, we're going to go ahead and click Finish, and then it asks, would you like the walls that go up to this floor's TopoSolid level to attach to its bottom? The answer to this question is no, and I'll explain why when we look at the section view. So I'm going to say don't attach, and then on this one it says the floor TopoSolid overlaps the highlighted walls. That means that we extended that floor into the wall. Would you like to join the geometry and cut it out of the wall? The answer to this one is yes, and I'll show you why again when we look at the section view in just a minute. All right, so it created our floor. Let's go ahead and take a look at a section view and see what that looks like. We're going to start with this one that we just made between the garage and the house. All right, so here we have an exterior wall basically between the garage and the house. Here's your floor system coming in here, and it's passing through both the third wall and this wall, and it did not actually do what I asked it to, which is to carve the geometry out of the wall. So I'm going to manually join those. I'm not sure why it didn't, but I'm going to manually join those two together. So I'm going to select the floor. Excuse me. I'm going to go to the Modify tab, click the Join tool, select the floor first. It's a little bit hard to figure out what I'm selecting, but when it highlights, you'll click it, and then we'll select this wall. And then what it did was it cut out that wall, but it left a little chunk on the bottom down here, and that's basically my mud sill down there. Okay, so the wall should extend into, the floor extend into the wall all the way to the outside face, and you can see our reference plane here. There's the boundary of our floor. That's exactly what that should look like. With walls that are in the basement, that are, in this case, this third wall is not going to pass through that floor like this in reality. What it's actually going to do and should do is stop at the underside of this floor. So the way we can make that happen is simply to use the Attach Top Base feature in Revit to connect the two together. Right here with that wall selected, we click on Attach Top Base, make sure this is set to top. We're going to define the top of this wall with this floor object. And you can see that it just trims it off. The nice thing about doing that is that no matter where this floor goes, the top of this wall will always be attached to the underside of it, which is what we want. So one more thing we can do, and I won't expect you to memorize this all right now, but I did want to at least introduce you to these concepts because we will get to a point where we're going to have to start thinking about what the wall sections look like. We want to make sure that they reflect real world scenarios. So the other thing we can do, other than joining that floor to the wall, which is what we just had done, I just undid that, is that we can stop the bottom of this wall at the floor by using the Attach Top Base. Okay, so let's go ahead and repeat that process, but now we're going to be using the bottom or the base of the wall. We're going to let this floor define where that is. So we're going to go ahead and click on, again, Attach Top Base. This time we're going to change it to Base right here in the options bar, and then we're going to set this floor as the base. And that does a couple of things. Number one, it stops only the portion that intersects with the floor, but it allows the exterior portion of this, the gypsum board in this case, to extend all the way down, which is exactly what they would do if this was going to be built in the real world. That gypsum board would not stop at the top of the floor. It would continue to cover the floor all the way down to the floor. The other thing that that does is it clears out this area down here where that mud sill should go, and it allows us to put in some detail lines to define what that mud sill actually would look like. So I'm going to go ahead and reattach Top Base between the third wall and the floor, and now we've got a wall section that looks very close to what we're going to be turning out in our final project plan. Now keep in mind what we just did there was pertinent or affects only the view that we're in right now. Let's go ahead and go back to the first floor plan, and let's take a look at this wall and see what it did over here. So this gets a little bit confusing because we're on the back side and this foundation wall is stepped in the back. This is on a sloping lot, so we'll just kind of have to parse through what's going on here. But you can see right away that the floor actually did carve the geometry out of this wall, which is what we wanted. We don't have to contend with a mud sill down here or anything. So this is exactly what this should look like. With just a few detail lines, we could clean this up and make it look the way that it should on the plan. We do still need to attach Top Base between any intersecting walls and the floor so that those come up and stop where they're supposed to. And technically, we would need to do that with any interior wall in the basement that was not already attached to that floor. Now, one curious thing you may have noticed is that the stairs disappeared, and that shouldn't really be surprising when you think about it because we just created a floor right over the top of those stairs. They do show up when you have the floor selected and highlighted, but in the default hidden line view, we're not going to see them. You can also make them display by switching to a wireframe view. You can now see those because wireframe is basically you can see through everything. But in a hidden line view, we don't. So we obviously are going to have to create a hole in that floor, right? We call that the stair opening. You probably remember that term. But the question is, where do we stop that floor? If they're actually going to frame this floor out, where would they create the boundary of that stair opening? And the answer, as you may have already guessed, is going to be aligned with the outside face of the stud on each of the boundary walls. Okay, so those walls will be built, they'll be framed right at the edge of that opening. Okay, so we're kind of having to think about some future things along with our current things that we're working on in Revit, which is typical. We're always having to think down the road a little bit, and the more you do it, the better you get at anticipating those things you need to do. But since these walls are already laid in there, we can just assume that we can cut a hole in this floor in a way that's going to align with both the top of the stairs and with the edges of the framing on those walls. So then how do we edit to create that opening? Well, you recall we created a hole in the last lesson right in the concrete floor, which we're going to get rid of later, but we need to create another one for the stair opening. So let's go ahead and do that now. And this, by the way, when we create stair openings, you can expect to go back and adjust that stair opening size at some point once we've done a stair section and established headroom and all those other funny things we got to do. But for now, let's go ahead and select the floor. Make sure that you have your select elements by face enabled so you can click on it. And then once it's selected, click on edit boundary, and that puts us right back in this sketch mode. Okay. Now, fortunately, once this goes into sketch mode, we can see through to the stairs and exactly where those are. So we know the upper portion of our boundary should align with the top of the stairs for this end. Down here is a little less clear. We don't know how far we need to get down before we can get our head under there. We may just be better off going all the way to the boundary of the floor itself because there may not be an option until we get around the corner that allows us to get in there. Just to be clear, this basement floor has an L-shaped stair, right? So I assume we're going to have enough headroom in here to get down, but we won't know until we do a stair section. So let's go back to the first floor. Let's create the hole in this floor. And what that consists of usually is just a rectangle, right? So I'm just going to draw the rectangle based on some snapping features here to start. And I'm just going to go up to this point right here. Okay. And I wasn't able to snap to anything at this corner. There was nothing over here to snap to. So I'm just going to move this line now over so that it's aligned with the actual stud. Okay. Now I've got that condition. Oh, it looks like it missed over here. So let's go ahead and move that one also. You can feel it snap into position. That all looks good. So let's go ahead and click finish. And it's going to, again, ask me this question. It's going to do that every time I edit the floor. Answer it the same way. Would you like the walls that go up to this to attach to its bottom? We'll say no. And now we've got our stair opening that we can see. Let's go ahead and cut a section through that stair opening just so we can see what's going on in there. We can check headroom and things like that in a preliminary fashion. And there we go. You can see that floor continues. In fact, what I want to do really is adjust that view depth so I could see that floor, but there's a wall going all the way up right there. And so I'm not going to be able to see it until I hover over it. And you can see that, yeah, there we can see that there's a floor passing through in the distance beyond. All right, so let's go ahead and just check the headroom just for fun. I'm going to go from this landing up to a point where I could see the bottom of that, and it's 6'2". So in fact, this particular stair opening is not going to be tall enough, wide enough to accommodate the headroom down into the downstairs. So what I'd really have to do is create an L-shaped opening to accommodate that. I need to cut more out of this floor to accommodate that 6'8" requirement. And this is just part of the design process. It might make more sense if I don't want to do that landing at the bottom and that whole L-shaped stair thing. I do have plenty of room here to create a different stair, don't I? I could add at least the number of treads that are at the bottom of this thing. I could add 3 treads and still have plenty of room for this hallway right here. So that's probably the best strategy rather than messing up my floor plan and having to carve out of this living room with a little chunk right here. For now, we're just going to leave it. I just wanted to make sure everybody understood how to edit a floor and cut a hole in it if necessary. So the biggest takeaway here that I want you to have is the boundary. The boundary of that floor needs to align with the outside face of stud, as mentioned multiple times before, but for whatever reason, that is one of the concepts that folks just typically have the hardest time conforming to or getting. It's not particularly difficult to do, but we definitely want to make sure that we're verifying where it runs. And as you can see, it does align right up with the outside edge of that framed wall. So I can't emphasize enough the importance of verifying with section views. Just create section views. They're super easy to create. They tell you a lot about what you've done, and they're also very easy to get rid of when you're done with them, right? You just kind of go through, select, delete, and they go away. Okay, we got one more floor. We got to go to the basement. We got to add that floor in there, right? We've been looking at section views all around this thing. Let's go ahead and go back here. You can see that down here, we have no floor down here. We have the bottom of the walls, and that's defined by the level, right? But there needs to be a floor in here as well. When we place that floor, it is going to come in as where the top of the floor is at the bottom of the wall, as defined by the level that you, again, can see in the south elevation view, or really any elevation view. So I have a separate layer in here for the stair landing, but this is actually the basement floor down here at 89, 11 3/4. You'll notice that is 4 inches above the top of the footing, which is what we would expect. So let's go to the basement plan. We're going to define the boundary of this floor where. And that's a question that you should always ask yourself. Make sure that you know you're being deliberate and you know what it is that you're trying to accomplish. Now it is easier to see over here because, as I mentioned before, we have a stepped foundation. So we have a combination of foundation wall at the 4-foot level, and then over in this area we actually have a framed wall at the 4-foot level. That's where our cut plane passes through our wall, which is why these walls look different. But the boundary of the floor doesn't really care what kind of walls are up on top of it. The boundary of the floor should start where? And if you answered the inside face of concrete, you are correct. Okay, so think back to the wall sections that you've drawn in the past, where that foundation wall comes in and sits right on the footing, and then the floor is poured over the top of that footing right up to the foundation wall, right? So that foundation wall essentially becomes the form for the basement floor. Let's go ahead and make one. So we're just going to build it in this area, this whole entire area. It will not be in this area because we've already got a floor there 4 feet up in the garage. Okay, so back to architecture, back to the floor tool. We're going to use a different type. This time we're going to use a concrete slab, 4 inches. And then we are going to define this by picking walls again. We can uncheck extend into wall core for this one. And then we'll just come in here and we'll try to find, not that way, not that place. We're going to try to find the inside face of concrete. And it looks like I hit that mark pretty well. So we'll just go around and click all the other walls. Looks like I missed on that one, so I'm going to Control Z and reselect it. There we go. Now for some reason it didn't clean up these corners. Normally it will, but in those cases you can just do the trim extend a corner when you're done. I usually like to wait until I'm all done before I clean those up. There's going to be one across here, and then one across the top, which I'm going to use this wall right here to define. And it looks like it went ahead and did those corners. So now I'm going to switch to my trim extend a corner tool and just make sure all my corners clean up nicely. I'm not sure why those ones came in like that. They normally don't, but that's okay. It's easy enough to fix real quick. Looks like that corner looks good. This one needs fixed. This one needs fixed. And that one looks okay. Now, if you miss one of those corners that isn't clean, it's not the end of the world. Revit will warn you, hey, you don't have a closed boundary that's legitimate. Go back and check your corners. We'll click finish when we're done. And then this one, we're going to say no to. We don't want the floor to carve out anything on the walls, or the walls to stop at its bottom. Okay, so now at this point, it's a good idea to just, again, create that section view, various locations, and just make sure everything came together the way that you wanted it to. There we go. We have a floor, we have a wall sitting right on top of it, and all of it joins at the foundation and the footing as it should. These kinds of things can be cleaned up. They don't necessarily have to be, but for the views where you're actually going to see that, we definitely want to attach these exterior walls using the attach top base option, just so your section view looks correct. We also want to think about the detail level that we're assigning, right? And of course the scale that we would print this. Okay, so we have all of our floors. Let's go ahead and go back to our first floor. The next thing I want to talk about is creating shaft openings. And I just want to describe what that is. So first of all, where is it? It's over here on the architecture tab. It's in the opening panel. And there are a few different ways that you can create a shaft opening. You can create it through a sloping roof. You can create it on a face at any direction, or you can create it perfectly vertical. And a shaft is sort of like a void space. It's not really a physical object. It just exists to carve out portions of a horizontal thing, right? So if I wanted to, for example, put an elevator in the middle of my kitchen here, I could create a shaft opening to remove that geometry. It doesn't actually cut a hole in the floor. It just creates a temporary hole in the floor. So let's go ahead and just do one real quick. Okay, so I need to define a couple of things, both the size, the footprint of that shaft, but also the height and the depth of the shaft from my current position. So right now I'm creating that shaft on the first floor, so I'd want to give it a base offset of some negative number. So if I wanted to cut all the way through that floor, I need to make sure that it's deeper than the thickness of the floor. So I'm just going to make it 5 feet deep, negative 5 feet deep, so 5 foot negative offset, and then an unconnected height of whatever that thing is, right? So if I'm just wanting to cut through the floor, I might give that a 0 to 1 foot height so that it's not cutting anything else. If I wanted it to go up through the roof or other floors, obviously I'd have to either give it a bigger offset or run it all the way up to another level above someplace. But I'm just going to leave it where it is right now and click OK. Oh, first I got to draw it, right? So I got to define the boundary. I'm going to draw a little rectangle here. Now I'm going to click finish. And it doesn't look like it created anything there, and I'm not really sure why, so let's switch to a 3D view and see where that thing went. Okay, so I've shifted to a 3D view, and I think I see why it didn't cut the hole in the floor. I only made it a foot tall, but I started at 5 feet below the floor. So let's change this to 6 feet maybe. And there it is. Now it created the hole in my floor. So you can see that when you hover over it, it is an actual object. It's just an invisible object that exists only to cut holes in things, right? And this object, if I select it and drag it, it'll move. It'll move that floor opening without actually doing anything to the floor itself. So that you can tell that the floor is still there. This is just cutting a temporary, almost temporary hole in it, virtual hole through it. So when would we use that instead of just changing the profile of the floor? Well, typically we're going to use a shaft when we're spanning a lot of floors. So if we're creating an elevator shaft in a building, for example, it would be better practice to create a shaft, because otherwise you're going to have to edit every single individual floor. And it's really easy to make a mistake or get that opening that passes through all of them misaligned on 1 or 2 floors and not realize it. So best practice would be to use a shaft opening You can adjust the size, the position, and it will conform to all the floors that it passes through automatically. Okay, so we're going to leave that there for now. Last thing I want to talk about is sloping floors. So I'm going to go back to the main floor for now, first floor, and we're going to talk about how to slope a floor if we need to. The most common reason to slope a floor would be to encourage water to flow toward a drain in the middle of the floor, for example. Okay, so if we had a floor drain here, we may want to slope the floor so that it is running downhill to the drain from all four directions. Another example of that would be a janitor's closet in a commercial building. You might have a floor drain in there, and you just want all of the floor edges around the boundary of that closet to all slope down toward that drain. In case there's a spill or something, we want that water to go into the drain, not seep under the wall or go other places. So sloping floors is a common thing that we do, especially with concrete, and we're going to demonstrate that now. Now, since we don't have any walls in here, I'm just going to kind of simulate a janitor's closet type of a scenario. Since we don't have any walls in here, I'm going to go ahead and jump onto the Annotate tab and the detail lines, and I'm just going to define a boundary of this sloping area using detail lines. And so we'll just kind of make it kind of small, and then I also want to define kind of where that drain would go. So I'm going to do that by using two more detail lines, kind of going across this thing so that it's right in the center. Now I could go further and draw a circle in there for the drain or whatever, but this is gonna work just fine. This is just something that I can now click on and trace that's simulating an existing room. All right, so now that we've got our setup, let's go ahead and click on our floor. We've selected it, and we're going to take a look at these other tools in the shape editing panel here. So one of the things we can do is modify sub-elements, and we're not going to mess with that right now. What I want to do is add 4 split lines that are going to basically define the boundary of our sloped area. Now we use this most often on roofs, flat roofs, to define the areas that slope within that roof system, but we can use it on floors as well. So go ahead and click on Add Split Line first, and then we're going to use these 4 corners to define where those split lines go. Now this is a little bit weird. It would be nice if they had a pick line option in here. We could just pick those 4 lines, but we're going to trace this thing by clicking points. So we'll click in this corner. You can see that it's looking for the next end of this split line. I'm going to define that as right here, and then it is set to chain. Here, make sure yours is set to chain also, so it'll ask for the next point, and the next point, and the next point. And we basically just draw a box in there. And when we're done, you can see that now when we hover over that floor, it's seeing that boundary as sort of defining the elevation of those edges. Okay, so let's go ahead now and get rid of, I'm going to go ahead and get rid of, whoops, cancel. This is why I like to turn off select elements by face, so I can draw crossing windows around things without selecting them. Okay, so I'm going to select all of these detail lines now, right? Actually, I'm going to select one of these detail lines and delete it. And I'll select another one, and another one, and another one. I'm just using a left to right crossing window. So now those 4 detail lines that define that boundary are no longer there, but we still see a boundary because that's now a split line edge on the slab, okay? We're going to leave these ones in here because I still want that point right there. The final step now is to select, and now that I've taken off the ability to select the elements by face, I now need to, select it by the edge by hovering over the edge. I pick my floor, and then I'm going to add a single point to define that slope. Okay, so I'm going to click on this tool, and then I need to make sure that when I create this point, it's going to be lower, right, than all of these other points that are defining the elevation of this slab. So I'm going to change this guy. No, I'm not. I'm going to change this setting right here to the new elevation that I want, which is I'm just going to drop it by an inch. 1 inch, minus 1 inch. Okay. Now anywhere I click, it's going to create a point that is 1 inch lower than the floor itself. And if I put that right here, it's going to create those slope lines. Okay, so now I'm going to get rid of these detail lines that I created, and now you can see that that whole thing is sloping down to a low point, which I just defined by that last point I picked. So it's not real obvious what happened. It looks like I just still have my detail lines in there. Those were just placeholders for the actual sloping that I wanted to do on this concrete. Let's go ahead and grab one of these section views and move it up here. I just want to kind of take a look at what I did in a section view. And here you can see that that boundary now of that sloping area, you can sort of see it coming down. This is that low point in the middle, and then it just kind of slopes back and joins with the rest of the slab. Okay. One final point that I will make is probably what they're going to do is not slope the bottom of this thing. So we have to do a little bit of trickery on the floor type itself to make sure that it doesn't do that. So I'm going to go into the type properties of that floor. I'm going to click on the edit structure. I'm going to change this layer from not variable from fixed to variable. And what that's going to do, it's going to allow the thickness as defined by right here to change if we have sloping surfaces. So I'm going to say OK, OK again, and now you can see the bottom of that is flat again. So the slope actually just happens in the top of the slab and not the whole thing. Okay, that's the end of the discussion. Hopefully all of that kind of made sense. You're not going to hang on to 100% of it perhaps, but when we talk about it again, you'll at least have seen it, and hopefully that makes the lesson in the book a little bit easier. Reach out if you have any questions. Otherwise, have a great break, and we'll see you guys on the other side.